Hello everyone, hope you're all doing great and welcome back to another video from devtechie.com. In this video, we are going to be learning about Gen AI and to be particular, what we're going to be doing is we're going to be setting up text-to-image generation using Stable Diffusion, and you can see how easy it is with just few steps to set up your own environment and generate your own images using Stable Diffusion. Okay, so first of all, what is Stable Diffusion? So Stable Diffusion is a text-to-image diffusion model designed to generate images based on textual descriptions. And the way it is used is users provide a prompt like a sunset over a beach, and then they receive generated images. Those images are generated using Stable Diffusion. Stable Diffusion basically leverages diffusion process combined with the latent space representation to efficiently generate high resolution images. And the model operates on a small latent space, basically a compressed version of the image, to make the processing computationally efficient. You're gonna see how, fast it is to set up a pipeline which can be used to generate your own images. So without further ado, let's go ahead and get started. We are going to start by importing some of the required libraries. Now we're going to be using Diffusion pipeline, and Diffusion pipelines are hosted on Hugging Face community. So Hugging Face is an open source community for all Gen AI related models. So I would highly encourage you to go and check that out. So if you visit huggingface.co, you're going to land on this page right here, where you can see there are a bunch of models that have been hosted. So it's a place for models, various kind of models like audio, text to text, image, text to text. Like there are several multi-model, computer vision model, NLP models, audio, tabular, reinforced learning, and there are some others, right? So not only individual contributors are basically contributing into this community, but large companies like Meta, Nvidia, and Microsoft, they're also putting their own models into this space. So it is one of the central place for you to go and check out what is new happening in Gen AI space. Okay, so let's go back into our code, and we are going to be working with Google Colab. So you can access Google Colab by going to collab.research.google.com, and as long as you have a Google account, you should be all good to go. And Google Colab is exactly same as the Jupyter Notebook, with all the feature functionalities that you have used in Jupyter Notebook, given that you're using environment provided by Google. And Google actually provides you GPU resources, so you can actually see what kind of resources that you can have. You can have the runtime. You can run these on TPUs, GPUs. If you want to upgrade your license and purchase additional computation units, then you can go for faster GPUs as well. T4 GPU is going to be fine for our use case. Okay, so with that, let's go ahead and get started. So first we're going to import basically diffusion pipelines. So we're going to say from diffuser. Okay, import diffusion. I'm waiting for Google Colab to help us out here. So first of all, we're going to import from diffusers from diffusion pipeline and DPM solver multi-step scheduler. Multi-step scheduler. There you go. Okay, so diffuser is basically, again, diffusers contains a library by Hugging Face for working with diffusion models, commonly used for generating images, text, and other output-based trained generative models. For example, in painting, out painting, replacement, and text to image or image to image generations. Okay, so once we have imported our diffusers, we are also going to make sure that we import torch for PyTorch library, which is going to use the tensor computation and for machine learning. Okay, so we're going to import torch. Okay, now we're going to select what Google Colab is suggesting and then go ahead and run this. And as soon as you run, you're going to see that your this line is running, and Google Colab is going to basically get a cache, and it'll cache all these libraries for you. And you're going to see this check mark with time stamp, so 13 seconds it took to run this particular line. And that's what, like, this indicates that we are ready for our next step. Okay, so next what we want to do is we want to provide a repo. Now we're going to provide a repo ID which specifies the Stable Diffusion 2 base model, which is hosted on Stability AI. And Stability AI repository is again hosted on Hugging Face. Hugging Face is Model Hub, and Stable Diffusion is basically provided by Stability AI. Okay, so we're going to create our repo ID, and this repo ID is going to refer to Stability AI. So we're going to refer to Stability AI repository. And we're gonna basically refer to the model that we are gonna use. So this is stable dash diffusion, and we are using version 2's base model, so 2 dash base. Okay, now I want to make sure that I've actually not made any typos here, so I'm just gonna try to replace this. Okay, there we go, no typos. All right, perfect. So we're gonna go ahead and run this as well, and it took 0 seconds to actually immediately execute it. So now we are ready for our next step. Okay, so we have so far imported all the necessary libraries, and we have defined the model repository which we're going to reference for this particular task of Stable Diffusion. Okay, so next we're going to load pre-trained model pipelines. Okay, now we're going to use diffusion pipelines, and diffusion pipelines basically provide a pre-trained model at a specified repo ID, and this is where you can specify the tensors that should be created in order to run this pipeline. Okay, so let's go ahead and create a new variable called pipe, and we're going to use our diffusion pipeline dot from. Okay, I'm trying to make sure that it actually autocompletes so we know that we are typing it correctly. So from pre-trained, and again we are using the pre-trained model. Okay, so pre-trained, and we're gonna open parentheses. First parameter is the name and the path of the model, as you can see here. So you're gonna define our repo ID here. We're gonna set up, like, the repo ID that we created up above. And next is basically the torch data type, torch D type, and torch D type is going to be torch.float16, which specifies that tensors that should be used are 16-bit floating point precision, which actually reduces the memory usage and speeds up the computation. The full, this is the half of traditional. So, like, you have 32-bit floating point precision, but in order to reduce the memory size and memory consumption and speeds up the computation, you can half it by specifying float 16. That's what we're gonna do here. Okay, so we're gonna say torch underscore the type, and we're gonna define torch dot float 16. Okay, now next parameter that we're gonna pass is going to be the variant fp16. Now this ensures the compatibility of a variant of the model specified, and this particular variable is optimized for float 16 precision. Okay, so this is related to the model, so we're gonna simply say the variant, and the variant that we're gonna use is going to be fp16. Okay, and once we have created our pipeline, we're gonna simply execute this, and this will download all the model, and it'll fetch all the files that are needed in order for our pipeline to execute. Okay, now once this pipeline is executed, we're going to go into the next step, which is basically changing this scheduler. So pipeline provides its own scheduler. We want to make sure that we control the scheduler by providing our own scheduler, and we're going to be using DPM solver multi-step scheduler. Okay, now this DPM solver multi-step scheduler is a scheduler that controls how the noise is removed step by step during the image generation process. And DPM solver multi-step scheduler is a specific type of scheduler that is designed for efficiency and quality. Okay, and what we are going to do is we're going to replace the default scheduler to improve the balance between the performance and quality of the generated images. Okay, and this is often used for faster conversions without sacrificing much of the accuracy. That's why we are actually going to override this. So let's go ahead and create a new code block, and we are going to say pipe dot scheduler. I just realized that my font is very small, so let me increase this a little bit so you all can see it better. Okay, so pipe dot scheduler, and we're gonna override this with DPM scheduler, DPM solver multi-step scheduler. Okay, DPM solver multi-step scheduler, and we're gonna basically rely on we're gonna use from config, from underscore config. There we go, and we are going to get the config from the pipeline itself. So we're gonna take the same configuration that is created in our pipeline when we created the pipeline. The scheduler, default scheduler, was assigned to it, so there's a configuration attached to that one. We can actually fetch that configuration and assign it to our DPM solver multi-step scheduler. Okay, so pipe dot scheduler dot config. There we go. Okay, so now we have our pipe dot scheduler overridden, our default scheduler overridden with our new scheduler. Okay, now we are ready to move the pipeline on GPU. Okay, so we're just gonna create a new code block, and two are created. That's fine, we're gonna need two of them. So we're gonna say pipe is equal to pipe dot to, and we want to move this to CUDA. Okay, and this basically CUDA refers to NVIDIA's GPU, and what this statement pipe.to does, it moves the entire pipeline, the model and weights to the GPU for faster computation. Okay, so we're gonna simply say CUDA here. Okay, CUDA, and we are ready to execute our pipeline on GPU. Okay, so overall, what we have done so far is we've set up the code for this using the stable diffusion 2 pipeline for text to image generation. Okay, we have loaded the model with reduced memory requirement. That's why we provided float 16 as the precision value, right? And then we actually switched our scheduler to use a scheduler that actually is more efficient for generating images, and then we enabled the GPU. So 3 steps that we have done. Okay, now the 4th step is the actual step to provide the prompt and generate the image. So we're going to simply say image is equal to pipe, which is our pipeline, and here we're gonna provide our prompt. Okay, so let's provide a prompt: astronaut. Actually, let's see, a futuristic cityscape. Okay, a futuristic cityscape, and we're gonna get an image generated from it. Images are generated in an array format, and your image is found on 0th index. So we're gonna simply have image here, and we are just going to put image dot show like so. Okay, so let's go ahead and execute this, and now we are going to generate our image. Okay, so there are going to be 50 inferences that's going to take to generate the image, and our image should actually show up here. I think maybe we need to do something like this. Image.show probably was. Okay, there we go. So as you can see, our image is generated, and this image is generated entirely from scratch. Like, you know, we have defined our prompt, and this image is generated by GenAI for us. Okay, so let's go ahead and try something else. Puppy on beach. Let's go ahead and try this, and we're gonna see that we get a puppy on the beach. Okay, all right, puppy with glasses on the beach. Okay, let's go ahead and see. There we go. So we have a puppy with glasses on the beach. This is how you actually generate or create your own pipeline to generate images from text. And as you can see, that apart from the import statement and setting up the repo, it only took 1, 2, and 3 lines of code to set up at the end, to set up the pipeline, and then 4th line to define the prompt and get the image. So 4th and 5th line. So roughly in 5 lines, you've actually generated an entire pipeline that can basically create an image from your user's text prompt. Okay, with that, we have reached the end of this video. Thanks again for watching, and I will see you guys in another video.